So BioEcho Life Sciences has been founded in 2016, and our goal is to set new standards in molecular diagnostics and life sciences through innovative methods, especially in the area of DNA and RNA isolation, where not much innovation has happened in the past years. So we are an experienced team with many years of experience in the field, with companies such as QIAGEN and GE Healthcare. So if you have a look at the analysis of a biologic sample in a diagnostic settings, it's the DNA analysis itself that is really making the pace here, whereas the first step, the isolation of DNA or RNA, really lags behind, and this is what we are working on. So we want to bring DNA isolation up to speed for DNA analysis by simplifying it, by speeding it up, by making it more reliably, and also by making it much more sustainable. So the goals ultimately is a patient's benefit, faster diagnosis, and basically also savings for the healthcare system. As I said, founded in 2016, so we are currently 15 employees, so we are a startup company. Our senior management, which is basically me, and I'm responsible for sales and marketing, and Marcus, on the other hand, we have been had leading positions at companies such as QIAGEN, Caris, and Bayer recently. We are located in Cologne in the BioCampus. What we are doing is we are developing technologies, and from these kits and procedures in our laboratories, we manufacture them on our own as well, and then we distribute and sell them. So besides the consumables part, we also do custom development with selected companies where we develop or optimize workflows. We then manufacture what's coming out of this development workflow and sell them to our partners. And we are, for example, engaged in several point-of-care projects where we do introduce our enabling technology for closed systems in point-of-care. So if you have a look at the general workflow of a biological, now here we are. Of a biological sample analysis, it's the analysis itself, but it's always, the first step is always DNA or RNA isolation. If you have a look what happened in the analysis field, especially, it's run, for example, by technologies like next generation sequencing, and it has made tremendous advancements in the past years. You know that the human genome sequencing took a decade and billions of dollars. Today you can do that in a couple of hours for a few thousand euro. On the other hand, the first step, the DNA isolation, is really lagging behind. It's still the same technology that has been used in the 80s. It's low complicated, it contains an inhibitory reagents and other environmental issues. So one can certainly say the speed, sensitivity, and so on these needs are met on the analysis side for the future, but the current technologies on the nucleic acid isolation, they really lag behind. So, and this gap is actually even more increasing than it's shrinking, and this is what we work on. So we want to reduce the gap between sample analysis and DNA as a first step. So if you have a look at what the competition is doing. It's all the competition. They all work basically with the same technology. It's that so-called silica-based process. We don't have to go through any details. It's just it's lengthy, it's complicated, and it takes hours to sometimes even overnight. We are doing that entirely different. So we start also with a disruption of a genomic, of a biologic sample to set the DNA free, but once then this lysis has been done, we pass that lysate over our purification column and do a single purification step, and then we have the DNA in the flow-through of that column. And it's significantly faster, so like in a thing of minutes, And if you have a look how that is looking finally in a single spin format, you see for blood isolation, you see the hemoglobin is held back by the matrix here in this column, whereas in anything else like salts or other inhibitors are also retained, but the DNA is in the flow through in a high purely form. So dramatically faster, significantly easier to handle, and even has a better performance yield and in DNA integrity. So this is for example, what we did on a protocol that contains 28 steps, was an overnight protocol with nasty ingredients such as phenol and so on. We took that protocol from a customer and improved it to a 1-hour protocol, improved the yield, reduced the steps significantly. And in the meantime, we have come up with that ultra-fast technology where we increased the step even further and reduced the time to 5 minutes. So this is going to be the technology that is, as we expect, to transform the industry. It not only works for this sample type, it's DNA from sperm, an important sample type for the animal breeding area, but it is applicable to all, to most if not all sample types. The rest of or a few more advantages and technology and features is the DNA is highly pure. Therefore, in downstream analysis, like quantitative PCR, we see a significantly increased sensitivity, up to 16-fold. We do not use any toxic or inhibitory reagents. Instead, our process works under aqueous physiological conditions. Requires less plastic, and that leads to a reduced health risk for the user and a saving of 70% of the plastics. You see that here in the picture, the plastic waste from a traditional kit compared to our kit. The purity also leads to the fact that there is no failure in downstream analysis, no rework. Customers like that a lot, especially if they work on high throughput. And that leads to a much faster time result for our customers. Processes are up to 20-fold faster. So this is really significant. And it also relates to the cost then and an increased profitability for our customers. We have a case study here from a precision medicine company, which when upon switch to our technologies are able to improve their reimbursement potential and thus their profitability by 30%. So by that, we have, instead of leaving the DNA purification development going somewhere, we reduce this gap or eliminate it even with our ultra-fast technology. It's fast, simple, it's reliable, and it's sustainable as well. What we currently focus on in the relatively diversified market is, besides life science and clinical research, on molecular breeding and animal and plants, where the throughput of DNA analysis is tremendous, and these benefit a lot from this increased speed. We also address already parts of molecular diagnostics, and so that area that we currently cover has a market size of 2 billion. Ultimately, we are going to move into molecular diagnostics of human biological samples as well. I think we are pretty well prepared for accelerated growth. So since our market entry in the end of the 2017, we have experienced a growing base of returning customers. We are represented in the most important countries in Europe. Just this week, we have signed a global distribution agreement with a very well-known company. It needs to be disclosed still. Everybody knows this company, and they're going to distribute under their brand. So we are doing co-development projects in the point of care area in both the veterinary and the human diagnostics space. We recently launched our high throughput portfolio earlier this year. We have a good IP protection of our system, and the company is fully digitalized. As to the financial planning and our revenue development, since entry in the market late 2017, we experienced a nice growth, especially in the markets of molecular breeding and molecular diagnostics. Our revenue goal for this year is 300,000 euro, and we have aggressive plans to increase that to the 80 million area by 2024. Break even is expected for 2021, and in 2024 we expect a market share of approximately 3%. Now, in order to sustain our current growth, we are looking for a new financing round. We are looking for 5 million euro increase to fund building of our own sales force, to build and improve our brand recognition, and finally also to accelerate our R&D pipeline, and to scale up manufacturing, and finally go into the IVD development as well. So to summarize, BioEcho addresses an attractively and large and fast-growing market of nucleic acid purification. It's approximately 4 billion by 2023, but it's still based on an outdated technology. And the market is challenged by increased sample throughput, so there is definitely a need for an increase in sample efficiency, robustness, and simplification of the entire processes. So BioEcho is well set up to meet these customer needs. We have an experienced team, we have disruptive technologies, and a well-filled pipeline. And in order to increase and sustain our growth, as I said, we are looking for a 5 million investment. And you are welcome to join us in our success, in our journey, and invest in BioEcho. And I'm happy to take questions. Thanks for your attention.